Welcome to the Seaward Pat Refresher webinar series. This is session number 7, Pat Risk Assessment. Hello, my name is Kevin Smith. I'm Category Manager here at Seaward, and I'm going to be taking you through this webinar series. If you'd like to connect with me in relation to the topics discussed in the webinar, or just about Seaward in general, you can contact me via Facebook, where I'm active on the Pat Testing forums, or you can connect with me on LinkedIn. So let's have a look at the agenda for the webinar today. So this is session number 7 in the Pat Refresher series. Obviously the Pat Refresher series has been now running for 7 weeks. This is week number 7, and we've got one more session coming up next week. And the series is designed to actually take you all the way through the topic of Pat testing from start to finish. Now obviously this is session number 7, and for those of you who missed out on previous sessions or want to review the topics in there, all of the previous sessions are now available on YouTube for you to view and go back over the content, so always worth checking that out. And also if you've got any colleagues or friends that you'd like to refer to that, obviously they can check those out too. So this is session number 7. We're going to have a look at Pat risk assessment. So as part of that, we're going to look at the law and the purpose of risk assessment. We're going to look at the factors that should be considered, methods of risk assessment, and a few tools that can help you with the risk assessment process. Then at the end of the session, as usual, we're going to open up to the group Q&A. So during the session, you can type in your questions into the chat box and I'll answer those as we go. But also, any of the bigger topics or anything like that that's a bit more detailed, have been asked by a few people, we'll answer those in the live Q&A at the end. So please get your questions in as we're going through the session, and like I say, we can discuss those at the end. So with that said, let's get started. So the first thing that I just want to go through, this is really a recap, and a lot of this was covered already in session 1 actually, but I think it's worth restating that. That's obviously quite a long time ago now. So if you are sort of new to this, again, I would recommend going and having a look at session 1. So one of the questions we addressed in session 1 was, is PAT a legal requirement? So the law surrounding PAT is not black and white as you may think. Often many of our assumptions about the law have no legal basis. Two common examples are that the law says we must PAT test every 12 months. Not true. There's nothing in there that says that. And that we all only need to test portable appliances. There's always great debate over, well, it's not portable. A washing machine's not portable, so it doesn't need PAT testing. And again, that's just a myth. That's just something people believe. And that we only test items with a 3-pin plug on. So this is items connected with a plug. And again, we do fixed equipment. We do equipment that's connected to the fixed installation and things like that as well. So both these examples here have no legal basis, and you'll see that in the coming slides. So it's always important that we just understand a bit more about the legal side as we're going through. So the main areas of law that relate to PAT are our duties to ensure that equipment is maintained in a safe condition, and those persons undertaking PAT are competent to do so, and that we've carried out risk assessment. So it's very important. The risk assessment is actually a legal requirement. It is actually part of the legal duties. So just as importantly as actually carrying out the actual inspection, actually checking where the maintenance is required and using competent persons, we also need to make sure that we've actually carried out the risk assessments, because that is actually a legal requirement as well. It's not just part of PAT testing that we should do. Risk assessment is actually law, so really important that we understand that, and that's obviously the basis of why we're going through that in this session. So just to recap on here, because I think this feeds into what we're going to look at with risk assessment. The main piece of legislation relating to PAT testing, or that justifies PAT testing really from that side of things, is under the Electricity at Work Regulations 1989. It's Regulation 4, Paragraph 2. And this is a copy here of a quote from Regulation 4, Paragraph 2, and it says, as may be necessary to prevent danger, all systems shall be maintained so as to prevent, so far as is reasonably practicable, such danger. So what this is saying is we've got a legal duty to maintain systems to prevent danger. And we'll talk a little bit more about systems, what we mean by systems in a moment. But systems really means all electrical systems. because this being the electricity at work regulations, it refers to electricity particularly in the workplace. So from that side of things, it refers to all systems, and the legal duty is maintenance. So what we're actually looking at now is maintenance. Is maintenance going to be required? What are the consequences if we didn't do maintenance? So that feeds into risk assessment. And a couple of important caveats in there. We've got, as may be necessary to prevent danger, so we've got to do it enough to prevent danger, but it's also got to be reasonable and practical. And really, we always get this question quite often, because people generally use risk assessments not to, sort of assign control measures and manage risk, but they just basically use it to work out how often should I test. And that's maybe the wrong way to look at it, because risk assessment is more about actually controlling the risk, reducing risk in the workplace and trying to make things safer, not just how often do I test. But there's a judgment in here that we have to make. So what we do has to be reasonable, it has to be practical, but also it's got to be enough to prevent danger. So I think what I mentioned in session number 1 was, I could actually say, right, I'm going to test everything every day. That would be enough to prevent danger, but it wouldn't be reasonable or it wouldn't be practical. So again, it's that balance. And how do we arrive at the balance? Risk assessment. So risk assessment is how we actually achieve that balance between what's enough to prevent danger and what's reasonable and practical. So I mentioned that risk assessment was a legal requirement. So here it is. This is the quote from the Management of Health and Safety at Work Regulations 1999. So it says here, every employer shall make suitable assessment of the risks to the health and safety of his employees to which they're exposed whilst at work, and the risks to the health and safety of persons not in his employment arising out of or in connection with the conduct by him of his undertaking. That's quite a mouthful there, but really what it's saying is we've got to carry out risk assessments, and when we're carrying out risk assessments we've got to consider the risks to employees, but also people who aren't employed, like the general public, visitors and things like that as well. So always important that we consider those, but we've got a legal duty there to actually carry out risk assessments, and obviously PAT risk assessments are part of that legal duty. So we mentioned that we've got a legal duty to test electrical systems. So that raises the question again, what needs testing? So let's just have a look at that in a bit more detail. So Regulation 4, Paragraph 2, Electricity at Work Regulations, uses the term systems. And this refers to electrical systems and includes electrical equipment. So HSE document HSR 25 actually goes into a bit of detail about what we mean by electrical equipment, and it says electrical equipment as defined in the regulations includes every type of electrical equipment, for example from high voltage transmission overhead line to battery powered hand lamps. So we're going all the way from parts of the distribution network, high voltage overhead lines, all the way down to a battery powered hand lamp, a torch. There are no voltage limits in the regulations. The criteria are whether danger may arise. So that's a really important point when you're carrying out risk assessment, that you need to make sure that everything's considered. We talked about the myths with PAT testing, that we only do portable equipment, we only do stuff with a plug on and all those sort of things. But that's not true, and it's important that the person carrying out the risk assessment understands what equipment needs the risk assessing on it, so that it can be worked into the system and worked into the procedure. So it is important that we've got an understanding of that the Electricity at Work Regulations covers all systems, all electrical equipment, and it's not limited to whether it's got a plug on, what voltage it is, all those sort of things. If danger could arise from it, then we need to be doing something to ensure that it's maintained in a safe condition. Remember, the Electricity at Work Regulations applies to equipment used in places of work and to work equipment. So very important from that side of things that we understand what's actually covered in there as well, because sometimes people get confused about, domestic equipment, and does domestic equipment need PAT testing and things like that. So it's equipment used in place of work and work equipment. So really important that we have that little caveat in there, so again we understand when we are doing the risk assessments what is covered. So the duty holder must risk assess all electrical equipment used in places of work or for work purposes. This should include battery powered equipment, three-phase equipment, and equipment that is permanently connected to the electrical installation, such as hand dryers and cookers. Again, often these things get missed out. The risk assessment will determine the type and frequency of inspection and testing that will be carried out on the equipment and any other safety measures that will be employed, for example, RCD protection. So what we're advocating here really is a modern risk-based approach to PAT testing. Previously, PAT testing might have just been done on a sort of a regular basis. We just do it every 12 months. Nobody knows why. We just do it every 12 months because everything just gets done every 12 months. That's quite an old-fashioned approach to it. And generally, I've probably said before, the 12-month time frame is not brilliant because it's probably too long for high-risk items and not long enough for low-risk items. So it's this halfway house that doesn't really meet any criteria. So the aim really with risk-based PAT testing is to test proportionate to the risk. So in a modern risk-based PAT process, the aim is to put in place an inspection and testing regime that is proportionate to the risk. The person performing the assessment must gather and consider all the relevant factors. And you can see in this process on the right hand side here that what we're actually doing, we're compiling the asset register, we're getting a list of everything. So we're going around spotting all the equipment, making sure we've included, like I say, the battery powered equipment, the fixed equipment, the three-phased equipment, all of those things. And then we're determining the factors. So when we talk about must gather all the relevant factors, we'll list those later on, but it says determine here the environment, the user, the construction type. We go round and we actually determine all of these things. And we've got to do both of those before we can carry out the risk assessment. Once we carry out the risk assessment and we determine the level of risk, then we're in a position where we can define the frequency of inspection and testing, and then the rest of it is just performing inspection and testing, recording the results, labelling the assets, maintaining the records, and then the whole process continues in a cycle, and we've talked about this cycle before. But this is a modern risk-based system. So there's no such thing as a fixed inspection and test period. We don't just apply 12 months for everything. We're assessing the risk, we're testing, inspecting, testing proportionate to that risk, and then we're constantly keeping that under review. That's the important thing. The whole cycle continues because we're constantly reviewing this and making corrections. So if the risk increases, then we change the frequencies to affect that, and then that's built into the process. If the risk decreases, then obviously again we can change the frequencies to cope with that. If any of the factors change, we can build that into the risk assessment, and then we've got the outcome. So it's a risk-based system is the modern way that we do PAT testing now. We don't just pick an arbitrary 12-month figure or something like that. We test proportionate to the risk. And the reason we do that is, one, it's fit for purpose. It does the job, because risk-based PAT testing actually addresses the issue. It addresses the risk. And that's what we want to do. It's targeted. It's a targeted approach. But it's also a very efficient approach. It means we're spending our energy on the higher risk items and not so much energy on the lower risk items. And generally in most places of work, we're going to have less high risk items than we are low risk items. So actually it works out, we're putting our energy, we're putting our resources where it's needed. And that's really important. So risk is made up of two judgments. So whenever you're doing a risk assessment, you've always got to balance these two things in your head, these two judgments. The probability that we're going to need maintenance. What's the likelihood, what's the probability that we're actually going to need maintenance, that equipment is going to need maintenance? And then the impact. The impact, what if that maintenance doesn't happen? What if there's a fault? What if the fault occurs? So from that side of things, we're looking at the probability and the impact. And the two things together give us the risk. So what factors affect risk? So below are a list of factors that can affect the probability. So we said risk was made up of two factors, probability and impact. And these are made up of sort of sub-factors below them, really, from that side of things that contribute to either the probability or the impact. And some of them, you'll notice on the list, are there twice because effectively for different reasons. Certain things can affect both the probability and the impact. Typical example of that, the environment in which the item is used. So from a probability point of view, if we've got equipment in a harsh environment like a building site or out in the weather, outdoors, that increases the probability that the equipment is going to go wrong. Again, we've said on here about where it's stored, the environment in which it's stored. If equipment is stored in a damp area where there's condensation and that could cause corrosion, again, greater risk that maintenance is going to be required. If we've got equipment in the environment where there's dust, metal swarf, all those sort of things that's going to get inside the equipment and cause it to fail, again, that can increase the probability. So the environment in which the equipment's used is a really big contributing factor, and usually the first one you'll see on most lists when we're actually looking at what's going to affect the probability. The type of user. Now again, you might think, well, how does that affect the probability of whether it's going to go wrong? But if we've got a user who's, highly trained to use that equipment, and they understand how to maintain it and, always put it away, and they'll clean it and they'll put it back in the case and all those sort of things, that means that the actual probability of it needed maintenance is lower. Whereas if we've got a user who just picks it up, puts it down, chucks it around, that sort of thing, potentially we've got users who are the general public. So there's a potential for, maybe vandalism or damage that won't get reported. These are untrained users. They're users who aren't really sort of, bought into the safety of the equipment, really. They're never going to see it again, so they might treat it roughly. If we've got higher equipment's being hired, so it's a higher user or something like that, again, the probability is more. So the actual who is going to use the equipment does have a big impact on probability. Equipment construction class. Now again, you might say, well, how does this affect probability? Well, actually, if you think about it, if we've got class 1 equipment, there's an earth on there. So that earth may need maintenance. It may come loose, it may corrode, it may break free, all of those things. So potentially, class 1 equipment might have a higher probability of needing maintenance than other types of equipment. So class 2, for example, wouldn't have that. Class 2 equipment wouldn't actually require that. So from that side of things, class 2 equipment, there's nothing going to go wrong with the earth because the earth isn't part of the equipment. So again, it may be lower probability. Equipment type. Now what we mean by equipment type is it stationary, is it movable, is it portable, is it handheld? So again, you can imagine stationary equipment in general terms is going to be in one fixed position. It's not really going to be moved around once it's put in sight. The cable's probably tucked away behind it, so it's not going to get yanked or moved about. It's probably just going to sit there behind the equipment. So really, the chances of that type of equipment, or the probability of that type of equipment being damaged, is lower than something that's portable, that's been picked up, put down, the lead's been run out to a socket, it's been unplugged, plugged, unplugged, the lead's been moved around. It's a higher probability that maintenance might be required for portable and handheld equipment. And maybe movable equipment, something like a vacuum cleaner maybe, where you're pulling it round by the cable all the while and stuff like that. Again, greater chance that the thing's going to be damaged. So the probability increases with that type of equipment. So the type does make a big impact. Frequency of use, again, yeah, I mean, what we're looking at is something going to need maintenance? Well, if we only use it once a year, the chances of it needing maintenance, of it getting worn out, is a lot less than something that's been used every day. So that's an obvious one really to consider, the actual frequency of use. Type of installation method, again, is the cable just run across the floor, or is it tucked away behind the equipment? Is the equipment fixed to the wall so it's got fixed wiring? Is the cable running conduit or trunking or something like that, again, or flexible conduit? So all of these things affect the probability. Now, a few that aren't mentioned in the IT Code of Practice, but I thought I'd chuck these in because remember, this isn't an exhaustive list. There's loads and loads of things you can add to this list. Service interval or intended life cycle. So if we've actually got a piece of equipment that says that you need to change the filter, use the vacuum cleaner as an example, you need to change the filter every 6 months or something like that, then you can expect to need to maintain it every 6 months. If you set the inspection and the maintenance periods on that to every 2 years, then you can expect it to have gone wrong. You can expect something there because there's a service interval in there. If we have bearings or something that we need to grease every 3 months or every month or something like that, or after so many thousand hours use, again, that needs doing. If we've got brushes on motors, motor driven equipment, hand tools or something like that, the brushes need to be replaced after a certain period of time. So there will be intervals in there, and if we don't stick to those intervals, we're not actually going to keep the equipment safe. It's going to need maintenance. Now, intended life cycle again is an interesting one, because sometimes you may have, particularly like IT or computer equipment, where because technology moves on, or maybe because you lease the equipment or something like that, that actually that equipment is only intended to be in the business for maybe 3 years maximum, and then it's going to be scrapped and something else will come in. So again, there is those sort of factors to think about as well from that side of things. I mean, intended life cycle, you can also look at where you've got DIY equipment versus professional equipment. So if you've got a DIY drill versus a professional drill, the actual life cycle, the frequency of use that it's designed for and the length of time that it's designed to be working, the duty cycle, is totally different. And again, that can affect the probability of maintenance. One that doesn't often get mentioned, but is actually a good point, is the age of the equipment as well. As equipment gets older, the chance of it needing maintenance is more and more and more. So again, the age of the equipment is a factor that you could build in. So these factors are really important, and it's something that we need to think about. But all of these factors have an impact on the probability, the likelihood that we're going to need to do some maintenance. So that's only half of this risk assessment process. But you can see the number of factors, and I could have easily added a whole nother page worth of factors on there. Now, one that I've kept sort of to the end because I think it's really, really important to mention is previous repair, maintenance and test records. The best evidence that we can have of the probability of these things needing maintenance is our own previous records, because that's the records of that equipment in our environment with those users, and it's accurate, really accurate real world data. So if we've got a list of repairs that have been carried out, and we know, every 2 years it has to have a new lead and things like that, we can factor that in. Again, maintenance schedules we talked about, if there's any parts that need changing and any planned maintenance or predictive maintenance. And also test records, previous pat testing records, again, will give us a clue about any problems that have come up and sort of frequencies at which things have occurred. So probability, one of the best things we can look at is our own previous records of repair, maintenance and test. Now, the other side of the coin, if you want to put it that way around, is the impact. What impact, what changes the impact? What affects the severity, the seriousness of these things? So if maintenance is required, what is the impact of that? What's that going to affect? So really, sort of, how dangerous is it going to be? How big a problem is it going to be for us? So we put on here the environment in which the equipment is used or stored. And again, we had that previously when we were looking at probability, but it does have an effect on impact, because if we're in a wet environment and the equipment goes wrong, that could be dangerous. If we're actually at height and the equipment goes wrong, again, those sort of things, maybe we're up on scaffolding or up on a roof or something like that. So the environment does make a big difference. The type of user, again, we might have vulnerable users. So again, we've got maybe a hospital patient or something like that, or maybe an elderly person in a care home. Again, that could affect the severity of it. So it is important that the type of user is factored in. We could have, primary school children or something like that in there. So that will affect the impact. Equipment construction class, again, one we mentioned before, but the severity of it, again, if no maintenance with class 1 equipment and we lose the earth, that could be somebody getting electric shock. Whereas with class 2 equipment, chances are we wouldn't get that problem. So again, the construction class is something that affects both the probability and the impact. Equipment type, handheld equipment. Where's it going to be when it goes wrong? I've probably said this before a few times. Where's handheld equipment going to be when it goes wrong? In your hand. So the impact side of things can be more important if you've got things that are handheld or portable from that side of things over something that's maybe stationary. But it just depends on what the type of equipment is and what risk it poses. Does the equipment provide an essential service? Again, this is a sort of knock-on effect. This isn't a standard one that's in the IET Code of Practice, but if this was medical equipment, if the medical equipment goes wrong, the impact of that could be a lot more severe. If it's potentially, a server or something like that, where you've got essential operations within your business, and that server could cause problems. Telephone systems, alarm systems, all these sort of things. So again, that's maybe something you want to factor in if you're looking at the impact. Other control measures in place. So again, how do we affect the impact? Well, there is other control measures that may well affect that. So if we've got a piece of equipment, the risk of it could be high. So the probability could be high or the impact could be high. But if we've placed an RCD on that, that could reduce the impact. It's not going to affect the probability, but it could reduce the impact. So there is other control measures that we could put in there, like PPE. PPE is another one in there. So if we're actually using PPE and the equipment goes wrong, again, that can reduce the impact. So generally, when we do a risk assessment, PAT testing is just one of the control measures that we might specify. We might specify training, we might specify signage, we might specify RCD protection, PPE, all sorts of control measures that we could specify, to control the risk. So what we want to do is just not think about just PAT testing. What other control measures can we do to bring that risk down overall? So risk assessment methods. In this section, we're just going to have a look at the different methods of doing risk assessment and what our options are really from that side of things, and really why one is better than the other. So there's many different methods available to us when assessing and documenting risk. So one very common option that we've got is IET Table 7.1. Now in the IET Code of Practice there is a table in there called Table 7.1, and Table 7.1 has got what they refer to as initial frequencies. So what they've done is they've basically said, if we don't know the factors, or we know very little about the factors that are in there, and we're coming to test a piece of equipment for the first time, we could use the table in Table 7.1 and we look up in there the type of equipment. Is it Class 1 or Class 2? Is it handheld? Is it portable? Is it movable? And what environment is it in? Is it in a commercial kitchen? Is it in a school, an office, a hotel? And there are standard values that they put in that table that we can choose from. Now, those standard values have just been derived by, sort of committee, for want of a better term, and they don't really relate to your specific workplace. They are very generic, they are very general. They may not be particularly up to date nowadays. So just picking values out of a table doesn't really fit in. And it does say above the table that they are initial frequencies. They're supposed to be really frequencies you could use if you just got a new piece of equipment, you haven't really got much data on it, use that. But then next time round, we should be keeping that under review, we should be changing it, we should be adding to it. So really that's something, again, that we need to factor in and we need to be aware of, because just picking values from Table 7.1 and using that forever isn't actually what it says. That isn't what's meant to be in there. So Table 7.1 is a risk-based approach. There is different values based on the rough perception of risk, but it's not specific to your environments. It's quite rigid. Trying to find a column or row on there that's actually perfect for your particular application may be difficult. And also it doesn't really take into account additional factors. I talked about RCD protection or something like that. So you can't really alter it, you can't really change it. Now, one caveat that I will mention is we've talked about later in the year, the 5th edition Code of Practice is coming out. And in the 5th edition Code of Practice, Table 7.1's been removed. So we've actually taken that out of the 5th edition Code of Practice now in favour of more detailed risk assessment methods that you can actually adopt. So at the moment, Table 7.1 is an option, and a lot of people do go down that route. They just use Table 7.1, or maybe even sometimes the HSE have actually got a table in their HSG 107 document, and sometimes people just pick the values out of there, and well, that's the values that's in the book, so that's what we use. It's not really a risk assessment process, and remember, we are legally charged with carrying out risk assessment. It doesn't say just picking values out of a table. So you probably would still need to do risk assessments, even if the result of it was that you said, well, the control measure I'm putting in place is I'm going to assess based on this table. You probably still need to document the risk in the first place. What I haven't included in this list, actually, because it's not really a method at all, is this every 12 months process as well. So similarly with that, just any fixed arbitrary time that somebody says, 12 months, 18 months, 2 years, whatever it is, again, it's not a risk-based method. It's just an arbitrary figure that somebody's arrived at. Now, probably the most granular and the most detailed way of doing it, and arguably the most accurate way of doing it, is an item level risk assessment. Now, what I mean by an item level risk assessment is we are going to carry out a risk assessment for every single item of electrical equipment within your business. So every single bit of equipment will have an item level risk assessment carried out on it. Now, that's brilliant because you can work out who the exact users are, the exact environment, the exact type of equipment. So it's a really detailed risk assessment. It's a really detailed way of doing it. But you can imagine if your organisation's got, say, 10,000 assets and you're going to risk assess every one of those assets, that's a resource. There is a resource there that needs doing, that needs accounting for, needs paying for. So again, item level risk assessments are really the gold standard. It would be absolutely perfect. And one of the things we've actually built into our pat testing systems that I'll talk about a bit later on is you can actually carry out and record item level risk assessments using, for example, our Apollo testers. So you can do it. You can do that. You can take photographs. You can record the data. So you know there is options out there for doing item level risk assessments, and particularly for organisations that maybe don't have a lot of items or only have a small amount of maybe higher risk items, then item level risk assessment is really the gold standard, and it's the perfect way to do it because you are looking at that individual piece of equipment in that environment, and you can really dial your control measures in to suit that piece of equipment. Now, group level risk assessment. Group level risk assessment is excuse me, is actually grouping items together and treating them because they are similar in their level of risk. So we might say within our organisation we're going to group together all handheld equipment. Or we might say we're going to group together all handheld power tools maybe. And we actually call that a group. So we say because where they are is generally similar, how they've been used is generally similar, our assessment of the risk they pose is generally similar, we're going to say, right, all of those handheld power tools are a group, and we're going to carry out a group level risk assessment to actually assess their risk and determine how often we're going to test those. We may say office equipment, so we may say office equipment, IT equipment. We may say fixed equipment, workshop equipment. It depends how you split the groups up. The groups could be a physical area. It could be everything in that particular building. It could be everything in a workshop is treated, everything that's in offices is treated differently to everything that's in a workshop or a factory. Or hire equipment is treated differently to, normal equipment. So it depends how you actually draw up the groups. And obviously when we talked about item level risk assessments, the smaller the groups, the more you can dial those risk assessments in and the more accurate it's going to be. So having group level risk assessments is probably more along the lines of what most people would do. They would actually define groups. They might get it down to, 5, 6, 7, 8 groups within the business. And then they'd perform risk assessments on those. They would determine frequencies based on those. And as a result of that, they would create a pat testing policy. And the policy would say, right, this type of equipment is going to get tested every 6 months. This type of equipment is going to get tested every 12 months. This type of equipment is going to get tested every 2 years. So from that side of things, actually using groups and group level risk assessments is actually a sort of a good way of doing it, in my opinion, really, because it removes the sort of onerous nature of item level risk assessment, but it still means that you can adapt and actually put those policies in place. Now, this is something that isn't present at the company level risk assessment. Company level risk assessments, really, we're talking about this sort of, fixed 12 months process and that sort of thing. So it's just everything in the company gets done every 12 months. Or everything in the company gets done every 6 months, or maybe sometimes people do have very basic groups, so they might say, right, everything in the offices is done every 3 years, everything in the workshop's done every year. Now, the reason that they're not very good risk assessments that way round is because they're not based on risk. A lot of the times these things are based on convenience. It's convenient to test everything in the school in the summer holidays. So we'll set a policy that we do all the PAT testing in the school in the summer holidays. Even the high risk items, the low risk items, we don't treat them any differently. We just do everything at that time. So really calling it a risk assessment is probably wrong, because a lot of these things aren't actually based on risk, they're based on convenience. You could say with a smaller business that you could look at a smaller business and actually say, right, the risk is common because of what we're doing. So if you were a tradesman maybe going into, a plumber or something, you could maybe say, well, all of my stuff is similar risk. Therefore, at a company level, I'm going to do this. So with small businesses, individual tradespeople, that sort of thing, maybe a company level risk assessment works. But generally, a lot of company level risk assessment is just really, in my view, lazy management and convenience based, as opposed to actually looking at the risks and actually doing it from that side of things. But many companies still go on that basis, and we just do everything every 12 months. That's what it is, and and it's better than not doing it. Don't get me wrong on that. It's better than not doing it at all. So in a lot of cases, it's not a bad way to do it. Like I say, I'd be worried about the high risk items, and you might be testing some things way too often, really, but better doing it that way around than not. So again, these are really the sort of options that we've got available to us. Now, whichever method you choose, you should document your assessment and the outcome. So remember, we're documenting the assessment, what we've done, but also the outcome. What's the control measure? What frequency are we going to test that based on it? There's no point just going, yep, I've assessed the risk, but what's the outcome? What are we going to do? What control measures? So there's no point just assessing it and then not acting on that. So the action part is really important. Now, for those of you who want to look into this in a bit more detail, there's loads of stuff on the HSE website. I've just picked out one document here. They've got a brief guide to risk assessments in the workplace. This is INDG 163, so this is an HSE publication, and it's a very small document. It's only a few pages, but it just gives you a good overview of risk assessment in a bit more detail. So again, obviously I haven't got the time here to go into risk assessment. It is based on generic risk assessments, not PAT testing risk assessment, so you've always got to factor that in. But again, I would always recommend go to these sources, people like the HSE, because they are health and safety specialists, and they are able to give you, really good detailed advice on here. So just following up on that theme, really, we've got a template. The HSE actually provide a template, and the Health and Safety Executive provide a free risk assessment template. However, this document is not designed for PAT and may need adapting. This template shows that we don't need to go to exhaustive detail to produce good risk assessments. So just looking at this in general, and I said it isn't designed for PAT testing, but this is just a template you can go and download off the HSE website. So the process they go through is to start off, what are the hazards? So again, for us, it's really, electric shock, fires, that sort of thing caused by electrical equipment. Who might be harmed and how? So again, this is looking at the impact of it, and really, what could go wrong with this. So we're looking at the impact on there. What are we doing already? So things like our existing control measures. So our existing control measures could well be we're using PPE, we train the staff, we've got RCD protection, all of these things. And at that point it says, and do we need to do anything else to control the risk? So it might be actually, no, what we're doing works. But it may be actually, no, we still think that the risk is still significantly high, in which case We need to do some extra things to control the risk. And then, as I said before, we need an output from that. So action by who, action by when, and then when's it done. So it's really documenting that in to say, look, if we're still not happy with the level of risk, and this action by who and when may be that we're going to do pat testing every 12 months. You know, when's it going to be done? Right, it's going to be done on the 1st of July. Right, was it done? Yes, it was. So it's that sort of back end of it, the actions that we have in there. So that's a very basic, generic risk assessment, but it's a starting point, and I'm sure you can come up with your own around that template or your own similar systems really to actually work out how you're going to carry out the risk assessments. Now, the next bit is interesting, and it's something that I'm sort of quite interested in really in promoting. Some duty holders like to use a score-based system to simplify the process of risk assessment. And I think actually if you can get these things into numbers, it does take away some of the sort of more qualitative judgments, shall we say, the decisions, the gut feeling side of things. Whereas if it's numbers, it does actually make it a lot clearer. So what do we mean by a score-based system? Well, we use a scale. Now, your scale can be anything you want, but I'm suggesting why don't we go from 0 to 10. So if we use a 0 to 10 scale, and we assign values for probability and impact. So 0, for example, would be no probability, it can never happen, never going to happen. And 10 would be a very high probability, it's almost a bang-on certainty that that thing's going to happen. Same with impact. Impact, what's the impact? None. No impact. If that thing goes wrong and stops working, from a safety point of view, there is no impact at all. But you could say, actually, no, the impact's a 10. You know, if that goes wrong, that's going to kill somebody. In which case, that could be a 10. So we assign these scores. So by using this sort of decimal system, this 0 to 10 system, it's quite straightforward. So then how do we get the risk? Well, we said the two factors affect risk. So all we do is we basically take the two values and then we multiply them together. And by multiplying them together, if you think about the ranges, 0 times 0 is 0. So the bottom end of the range is going to be 0. And 10 times 10 is 100. So from that side of things, it's a 0 to 100 scale for risk. So we almost get a percentage type scale or 0 to 100 scale for the risk score, which is nice and easy for everybody to get their heads around, and it sort of fits nicely really. But of course you could have 1 to 1,000, you could build in more factors, and a lot of people have a lot more complicated systems than this that they factor in. So what we can then do is once we've got that and we've got risk scores, we can actually create bands. And what I mean by bands is bands of numbers. So we could say, in this case for example, anything between 1 and 20, that's a band. And that band we would generally call low risk items. So anything that scores between 1 and 20 is going to be a low risk item. So we might want to do a combined inspection and test on that maybe every 5 years. You may decide that if you've got something under 10, say, that actually you're not going to do any testing on it at all. You're just going to do a visual inspection or you're just going to do user checks. So you may actually, for your very low risk items, decide actually we don't need to do any testing. The risk is so low already that actually the testing part of it we can omit. But you can imagine how we set up a band. So effectively we've got the bands and we'd say maybe 1 to 20, you know, sort of 21 to 40, 41 to 60 and so on, and we can put those bands in place and then we can map those, and then we can actually have that as a policy really for our organisation. We can say, right, anything that scores in here we're going to do this, anything scores in here we're going to do this. So what I've done, I've just stuck a quick example on here just to show you. So this is just an example, so a theoretical, say we've got a 9-inch grinder on a construction site. So let's have a look at the probability of that grinder going wrong. Well, anybody who's actually tested grinders on a construction site know that you get very few that pass. Because generally these things are beat up, they're used in arduous environments, they're used in all weathers, and they really have a really tough life. So the probability of maintenance being required when you come to check that piece of equipment, or at some point throughout its life, is pretty high. So I've given that a score of 9 out of 10. I've said from a probability point of view, the chances of me finding something wrong with that grinder when I come to it is pretty high. So the probability, I'm giving that a score of 9 out of 10. Now, impact. What could be the problems if there is maintenance required with this grinder if it does go wrong? So again, due to the environment that we're actually in, we're in a building site. You could be in a wet, muddy puddle. If somebody's going to get electric shock out of that, and also the equipment type, it's handheld equipment. So if we've got handheld equipment, it's going to be in my hands. I'm standing on a wet, muddy building site, maybe in the rain, using this thing. Something goes wrong with it, I could get injured. In fact, there's a very high probability that I would be injured. Similarly with, we've got the grinder on there. There's a 9-inch disc grinder, maybe a 9-inch blade spinning round there. Again, something goes wrong with that. There's a high probability that somebody could be injured. So in this case, I've given that an 8 out of 10. So we've got a 9 out of 10 for probability. We've got an 8 out of 10 for impact. So what do? The risk score equals 9 multiplied by 8 gives us 72. And 72 in my made-up system here puts me in a band that I've created between 70 and 90. So between 70 and 90, I've said that 20-point band, I've said that those things would get a combined inspection and test every 3 months. So depends how you set your bands up, and that's why these systems are quite good, because you can alter your bands, you can set your bands to suit the equipment that you've got. And it may actually be, you might have anything over 90 is just not worth it. So, we need to find another way of doing it. Anything that's that dangerous, that much risk, inspection and testing just isn't going to be enough. So maybe we need to find another way of doing it. So you may even have within your company policies things that's just like, anything that scores over this, we've got to find another way of doing it. We've got to do it with an air tool instead, or do it with a different type of tool, or battery powered equipment, or some way of doing it that actually removes that risk, because the risk is just not acceptable. Now remember, I've put in here frequencies for combined inspection and test, but we would also apply this system to user checks and to formal visual inspections. So remember, any risk-based system, you've got those 3 tools there that we use as part of the control measures. So although I've only talked about how often we do combined inspection and test, we would need to do the same process and maybe map our bands out for user inspections, formal visual inspections, and the combined inspection and test. So you can see there how we can set up a system with a quite simple sort of spreadsheet maybe in there. We have a policy. The policy has the bands, and you could quite easily, complicate this even more if you wanted to, because you could actually have scores that make up the probability. So you could have your sub-factors in there, and you could score each of the sub-factors, and then you add them together. That gives you the overall score, and then potentially do the same with the impact, and then you multiply those two together to get your overall risk score. So you can actually sort of automate this and really get it into a system that removes a lot of the judgment calls, really. It's just honest judgments about each of the things. That then gives you the number, the risk score, and then the risk score tells you what you need to do. So something you can look at and something you can put in place there, I'm sure. So one last little thing that we wanted to talk about really here is Seaward do have a number of risk assessment tools that are available to you to help you with this process, and I did refer to these earlier. So built into our PackGuard 3 software, we've actually got a risk assessment tool that's built in there that allows us to do the item level risk assessments. And I know it might be quite hard for you to see on the screen here, but you can actually put in judgments about the environment, the equipment type, construction class, users, type of installation, frequency of use, previous test results. And by answering all of those little drop-down boxes, it then assesses the risk band. So in this case, it would say high, and how often you should be doing formal visual inspections and combined inspection and test. So again, we've got that tool built into the PackGuard software, so you can enter items in, you can do the risk assessments, and then obviously using PackGuard you can schedule the retesting and you can do your reports based on that. That same tool is also built into our Apollo pat testers. So when you're actually using the Apollo pat testers, you can do a risk assessment, and as I said, you can actually do that for every item you test. You just go through, answer the questions, it sets the frequencies. But the great thing with the Apollo is it actually stores that risk assessment in the tester, and then when you download it to PatGuard, those risk assessments come through. So if anybody ever said to you, why is that been done every 6 months, you can say, here's a copy of the risk assessment. And if you've got the Apollo 600, you can even take pictures as well to support the risk assessment from that side of things. So it's a really interesting tool and a really useful tool in there that some people use. And for those of you who are commercial pat testing, you're pat testing for money, it is an extra service that you can offer. And as I say, from sort of September time when the 5th edition of the Code of Practice comes out, and there will be a greater emphasis on risk assessment, these are services that you can actually be offering and charge a premium, and actually say, look, if I'm going to do a test, it's going to be one price. If I'm going to do the test and I do a risk assessment for you, do you want me to do that? And I can carry out the risk assessment, and then, but it's going to be an extra, X amount per item or an extra price on the job. So again, there is, business opportunities potentially there, and we have got the tools. Now, also our Pat Mobile app. In our Pat Mobile app, we've actually got a risk assessment tool built into that. It's a bit more straightforward, but basically you can pick the construction class and you can pick the equipment type, and then that will work out the frequencies based on that as well for you. So again, we've got that built into the free Pat Mobile app as a feature from that side of things, and that's really aimed at people who are using our manual, prime test pat testers. But there's a variety of tools there available, and sometimes these things get overlooked. But obviously, we're saying now, later in the year, risk assessment is going to be a bigger thing, and we do need to have systems in place for doing these risk assessments. So why reinvent the wheel when they're already included in the Seaward products that you may already have or you're looking to purchase? So that was just a quick overview, really, just to show you what is available there to help you with the risk assessment process. So, conclusion. So in this session, we actually looked at Pat risk assessment. We looked at the law and the purpose of risk assessment. So we looked at Regulation 4, Paragraph 2. We looked at the management of Health and Safety at Work Regulations 1999, the risk assessment parts of that. And we talked about why we do risk assessment, to actually be able to make those decisions and decide that balance between enough to prevent danger, but also what's reasonable and practical, and that's really important. That's why we do the risk assessment. We looked at the factors that should be considered, so things like the environment, the users, the age of the equipment, all of that stuff, and I'm sure there's loads more that you can add in when you're actually doing this for yourself and actually start considering these in your real workplace. Method of risk assessment, so we actually looked at the options that are available to us, so just picking 12 months, or using the values from table 7.1, doing item level risk assessments, group level risk assessments, and even company level risk assessments to actually document those things. And we looked at how you could use templates provided by the HSE to do risk assessments, or how you could actually use score-based numerical systems for doing that. We finished up with a quick overview of the tools that are available there, and you can see that we've got tools available in the PatGuard software, the Apollos, and also our Pat Mobile app, which help you to actually do the risk assessments and determine the frequencies and record that data. So that's the end of session 7. Hopefully you found that useful. Next week we're going to be finishing up the series with documentation and record keeping. So documentation and record keeping is really the evidence that we compiled when we do pat testing. What evidence do we need there? How do we actually record that? What's the best options for doing that? How can we improve and streamline what we do, and all those sort of things? So again, really important from that. Now, just quickly before I talk about the Q&A, one thing that I wanted to ask people is, obviously we're coming to the end of the session, and next week I say is the end of the webinar series, is session 8. What I'm looking to do is actually add on some bonus sessions at the end, because these sessions have been really successful for us, and we're going to start putting some potentially some bonus sessions on, session 9, session 10, for example. So if you do have any ideas or anything that you'd like me to cover, to dedicate a whole session to, then please get in touch, please let us know, and obviously then we'd be more than happy to put those on. So for those of you who've gone all the way through the series, there may well be bits that you thought would be really great to get a session on that. So I've got a few ideas myself, so there's probably a few we'll be adding on there, but it's always great to get feedback from you guys on anything else you want. So now it's over to your questions. It's time for the Q&A session. So please type in your questions into the chat box, and we'll start talking through that. So thanks very much for your time. It's really great to see so many people turning out to these sessions, and they've been really popular. So now I'm going to stop the video, and I'm going to go over to the live version of me, and we'll answer your questions. Thanks very much for listening.